Hello, good evening. Yeah. So till last night, actually, till yesterday, we were discussing about the tree map and the collections related, couple of other classes, and we saw examples from those tree map and everything, tree map and other collections. Okay. So yeah, let's continue with the other topic. The next topic. Yeah, so we covered till here tree map. So the next topic we are going to cover it is like threads and the parallel processing. So 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 where exactly we use threads, right? So whenever we required something um, asynchronously, to call or to complete to complete the work. Okay, so without knowing without having any user presence or without having any user related steps required, in that places actually we generally use threads. Okay, so something like I something the example is, so whenever you wanted to require a bank statement or something. Okay, so if you want to get it delivered directly through your email, or if you want to get your statement through a paper like mail copy, from bank. So generally you go and you request, you log into your application, the net banking or someplace, and you request for your bank statement in the net banking. Okay, so that time actually, whenever you request it, it was not immediate, but it will be delivered it to you a bit later, or to the email. If you check it, if it is not immediate, actually it will be taking some time to generate the to 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 send you that PDF file with all the statement details. So what it happens, right, internally it is going to trigger a thread process. Okay, so an asynchronous process is going to be triggered, and that process actually will be running as a thread. Okay, to deliver the PDF file to the customer. Okay, so in that scenarios actually we are going to use threads, or any asynchronous process, or we have lot many options right now. So there are like Spring Batch, and if we wanted to go and trigger the Spring Batch concept, then we can utilize that as well, to send those, right? So thread is basically simple, like when it it is kind of um, to run the to run the code, or to run something asynchronously, without having any user interaction. We utilize threads, right? So how do we create threads? Okay, so threads can be created in two ways. Okay, one is thread class using, and the other one is, okay, runnable class. Okay, so let us check an example how the thread is going to run. Okay. Yeah, so the implementation which I took, it's like I'm just extending the thread class. I'm extending the thread class. Okay. So what I've done here, it's very simple. So in the public, okay, in the first class, actually I implemented run method. Okay, so when we extend thread class, there is a run method that we need to implement. Okay, so okay, so yeah, so what we have done it here in the threads, right? So in the run class, I've just added thread.sleep. Before starting this thread, I was just pushing the current thread, into sleep for 100 milliseconds, right? So in this, I'm just adding a true condition with a while. So that means, this is going to be our the never ending condition. So it will be running in a thread process. So system.out.println thread started running, and then I just took this one, until unless if results is equal to 20. If it is result is 22, then it is going to be sleep for 500 milliseconds. Okay, and it will print everything. So this will be running in loop. Okay, and what we have done at the main method, it's very simple. Yeah, so in the main method, I'm just creating a thread object of that class, and I'm just calling dot start method to initiate the call of run. Okay, so whenever you wanted to trigger run method, okay, of thread class, you have to call thread dot start instead of thread dot run. Okay, so start method will internally trigger run method. So here I was just trying to. Here I was just trying to show you like how the thread is going to start asynchronously. After T1 that start, actually this will start execute, but you know, um, directly after this, whenever we trigger T1 at start, immediately the next statement will be printed, and it is going to wait for just 1 minute, and it is going to print these ones. Okay, so you will be able to understand like how the statements are getting called and printed in the console. So let's see, try to run this application, try to run this program. Okay. Okay. Yeah. Okay. So if you see here, right, uh, you know, it printed before start. Okay, and immediately after start. Okay, and if you just observe why it printed immediately after start, okay, I'm gonna show you something. Okay. Because here, I just added thread.sleep for 10, 100 milliseconds, right? So that means, it is going to just wait for that time to be completed, and then it is going to start the run the thread, right? So now what had happened? Actually, it just completed, thread started running, and in here also thread started running. Okay, so that means, it executed these lines, and the result is 22. So it slept for 500 milliseconds, right? And the same way it repeated twice. Okay, it repeated twice. Then if you see here, it executed this one. Thread started running the main thread. Okay, because the main thread was sleeping for 1000 milliseconds, and this was sleeping for 500, right? So then it started running that, thread started running one and running two, and it completed. This one is done, and again our thread execution is started, and it is keep on running. Okay, so with this example, actually, I just wanted to show you, like, these are asynchronous calls, like, there is no dependency between these two threads. So we have to, if you really want to create a dependency between these threads, we have to communicate each other using threads, okay, with the notify method, in the thread classes. Okay, so we do have like a life cycle of threads. Okay, so we can utilize them, in the class. Okay, in the programs. Okay, whenever we are implementing threads in your classes. Okay, so that's how it does. And the next one is parallel processing and functional programming. Okay, so these are the two concepts which are introduced in Java 8, and which was having very, like, very much useful concepts, okay, to write the programs. So in Java we can achieve parallel processing using parallel streams. Okay, so stream API is used to process collections of objects in efficient way. Okay, so how we are going to do that? We will check an example, okay, from parallel processing, and also the functional programming for the lambda expression. Okay. Okay, so functional programming, I think, so far Java, whatever we are checking the programs, right? It's most likely like imperative style of programming, like, object-oriented style of programming, right? So the next big change, it's already done in Java, is has been added to the Java, has started supporting the functional style programming. So when it says functional style programming, so it's till now we were talking about high order classes, right? Whatever we do, we write it in a classes, and then everything deals with an object, right? So but when it is functional programming, so it is kind of, the functional programming higher order functions. What we can say in functional programming, functions are to be considered as first class citizens, like, so we can pass objects to a function, we can create objects within function, and we can return objects from a function, and a lot of new ways to speed up the code. Okay, so that means, instantly you can write some kind of instant code in the function, okay, which can create a class, and which can create a object inside of it. Okay, and you can perform all those operations inside, in that particular block. So one of the example that we are going to check it, in the functional programming, and we'll move ahead with that. Okay, so first we will verify about the parallel processing, and the second one we will go with functional programming. Okay, so now yeah, so in this program, right, we have just a class and public void method, main method. Okay, so this is like, calling system.out.println and normal. Okay, and so normal execution is something like, you know yeah, normal execution I'm just utilizing without any sorting order, and this is without using the parallel, sorry, and that I'm just using stream. Okay, in stream range is equals to in stream range close 1 to 15. Okay, so what it is going to do you, right, it is going to give you an output of 1 to 15. Okay, like, when you are iterating that range, in a for each loop. Okay, so in the line number 12, whatever we are using range dot for each, so system dot out dot println, so it is going to give you uh, the numbers in is in the numbers from 1 to 15. Okay, so when if you wanted to achieve that in a parallel manner. Okay, so the same thing, I took a range to with the 1 comma 15, and range 2 dot is parallel, and I'm just printing this one. Okay, okay, so let's see how it works and what would be the difference, right? Okay, so sorry. Java parallel example. Yeah, so if you see here, so when you see the normal stream, actually it printed with an order 1, 2, 3, 4, 5 up to 15. But when you see an order of the parallel processing, you don't have a proper order for it. Actually, it printed, uh, like it's not an order, but it printed all the numbers from 1 to 15, right? So parallel processing is little bit different when you compare to the normal one. So it is going to read parallelly, it is going to use your core. Okay, multiple cores, to retrieve that stream, immediately with the multiple threads. Okay, so it is going to read them with in a parallel way. Okay, for reading one comma 15 values. Okay, and okay, so and it is going to print in the same way. Okay, whatever we are doing for the normal range. Still, if you wanted to bring them in a sorted manner, you can still do that using, calling it dot sorted method before printing it. Okay, something like this. Okay, so there are a number of options, like, if you wanted to run this program multiple times, sorry, if you want to utilize this parallel stream, right? We have multiple other options. You can just go through those methods under dot, parallel, and we can have this for each ordered, right? So Java parallel example. Yeah, Okay, so it looks something like this. Okay, Java parallel example, and you know we are we are just printing in a sorted way now. Okay, even though it is a parallel processing, now it is we are printing with a sorted order using dot sorted. Okay, and for each order. Okay, okay. So the next example which I wanted to show you is stream example. Okay, so okay. So this is also like, if you wanted to utilize any, we have a collection like arrays that, uh, there is a list that I took it, which is having couple of strings, okay, inside it, and I'm just printing that, and there is a predicate, okay. So why we use predicate, right? We utilize this predicate, okay, to filter out something in the list, okay, so something in the collection, like let's say we are having like number of strings in a list. So I just wanted to filter out the words which are starting with G. Okay, so how to write those things, you can achieve that using predicate. Okay, so predicate is going to help you to filter out the strings under the list, or under a collection. Okay, you can just filter out and have only those strings can be written which are starting with your condition, whatever you mentioned. So predicate, I'm just using a string. Okay, so if you see here, predicate string, predicate is equals to new predicate. I'm just starting a functional programming kind of thing, right? So I'm just starting it here. I'm just overriding test method. Okay, and string s. Okay, so this s is going to be our list value, one of the list. Okay, object. Okay, one of the list param, like inside the string, it is going to pass it over here, and it is going to return only the strings which are starting with G. Okay, so that means we are going to filter it out with the predicate. Okay, and we'll be printing those values only which are starting with G, right? So let's see that how it works, right? Yeah. So first, initially we printed all the list and stream from the list, which item starts with G, good and ghost. So we can use the predicate, when in the streams actually to filter out. Okay, okay, and this is what the streams are used for: list dot stream and dot filter predicate, and you can just utilize for each, to print those things. Okay, so it made very simple, like when we are using the streams, okay, in our day-to-day programming. Okay, so this is one of the example with the streams. Okay, and the other one is lambda example. Okay, so lambda example is also pretty much looks very similar to that, and this concept is also introduced in Java 8. Okay, so now I'm just showing you, like, I'm utilizing the lambda expression in printing, um, you know an array list, okay, into in the on the screen, right? So what I've done, I just, you guys are already aware of this one. We are just adding a couple of elements, to the array list whatever we declared, and array list dot for each. I'm just writing this one, okay. So a lambda expression. So for each element of n, so the n means, like, you can consider the value whatever we are getting from the list for each and every object. So that means an integer, right? And we are just using that integer, with this arrow and, this one, lambda expression. So we are just printing it directly to the n. So I think you guys understand, like, it is similarly like for each loop, we generally use some int a colon, the object of the list, and, we usually print it. For now, we don't require that, the array list, because we were already using array list dot for each, okay, and we were just utilizing that, each and every independent integer which is under the list, and we were just utilizing system.out.println with n. So this is one type of, like, implementation of the lambda expression, okay. And the second way, if you wanted to print it, like if you wanted to utilize some conditions, okay, if it is even number or odd number, if you want to find out, so you can still implement a condition after this, okay. If, see, something like this, if n percentage 2 is equals to 0, so that means, system dot, then only, and I'm printing the values, right? So let's see how it works. Java. Yeah. If you see here, so first lambda, first if for each, right, it printed all the 1 2 3 4, and the second one it just printed only 2 and 4, because, it is divisible by 0, right? So that's how it does. And this is the example for a lambda expression, and very basic example. You guys can try something, in all the ways, like, wherever it is utilized, you can just try with this lambda expressions, okay. So, and if you have any questions or something related to this, let me know. Okay. I will, like, this can be, yeah, this can be implemented in many ways, in many places actually, lambda expression can be used, to minimize your coding, and, you know, it mostly enables all the functional programming, okay, with this lambda expressions. Okay, so let's go to the next topic. Okay. And so I'll just cover about the Agile and DevOps, and then we'll go with the Git source code management, in the next class. For today, actually, I'm gonna cover Agile and DevOps, related explanation. Okay. So let me open the PPT. Okay. What exactly the agile, right? Agile emphasizes collaboration between developers and product management, and but the DevOps includes the operations team. Okay, so including these people, and agile centers the flow of software from ideation to code completion, and DevOps extends the focus to delivery and maintenance. Okay, so whenever in the agile, actually, in the agile flow, in the methodology of agile, so we generally follow, to develop a software, and to until unless the code completion is happened, agile will follow those things, right? It emphasizes, right, to complete, until unless the code software development is done, right? But the DevOps, they are going to help us, to focus on the delivery and maintenance. And using agile, actually, we were going to continue the development, like, it's kind of an iterative process, and which includes like very small piece of code, or small piece of chunks, that we are going to deliver it every time, whenever we have, in the agile sprint, right? So every sprint, it is kind of an iterative process, will develop, and will deliver those things, to the, according to the stories, right? So in the DevOps, actually focuses more on the test and delivery automation. So it is kind of a combined thing, like, we what we do, and we develop the process, we develop the software, or we develop something, some new some new, um, you know some new code, and that has to be given to the DevOps team, okay, to focus more on test and delivery automations, like, okay, I'll show you those things, in the next classes, like how we develop, and how we going to, seamlessly integrate, to until unless it deployed into some environment. Okay, so it's a continuous process, right? So agile has structures to plan work for developers, okay, but DevOps incorporates unplanned work common to operation teams. Okay, so there are like agile 12 rules. Okay, so where we have to, like, you know where we have to load them, use them, actually, whenever we are, into agile process. Okay, so we have to follow these 12 principles. Please go through them, and if you have any questions or something, let me know. But when you compare with DevOps and Agile, Agile will more focus on, creating stories, and how to work on the solution. Okay, and it is going to break those, problems into solutions, sorry, problems into multiple stories, and each story will be having its own, development work. Okay, and it will be delivered in a certain sprint time. Okay, so all these combinedly, we deliver these stories, as an epic, and that will be delivered, into as a product, to the customer, right? So similar way, this agile follows, right? But what exactly DevOps does, agile is more responsible until you develop something and keep it ready, right? But we don't have, like, deploying those concepts, and deploying those pieces into LLEs and production, and to test it. So all these things can be automated by DevOps. Okay, so once you have the code ready, then DevOps can help, help us, to seamlessly deploy those applications, okay, into LLEs, and also, into production. Okay, and we have lot of other tools came in the DevOps, okay, which are helping, to automate the test environment, and automate the test cases. Okay, like, integrating with Jenkins, and you can call multiple other, um, you know Jenkins and other GitLab, and GitHub. Okay, so where we can automate this delivery pipelines, okay, to deploy seamlessly, without any issues, okay, into all environments. So we're going to see them, in further classes after discussing about the Git repository, and then, we'll continue on the other topics. Okay, so let's jump into the Git, what exactly Git, right? So before going to the Git, okay, I just wanted to tell you some, some story. Okay, so this will relate, to the Git concepts. Okay, and the story will continue until our Git, you know, uh, Git class is completely done. Okay, so there are three people, like, Rob, Sam, and Ted. Okay, so Ted is actually working on a film script. Okay, and Sam and Sam and Rob, joined him, later. Okay, joined him in on the same script. Okay, okay. So, and Ted is working on the film script, and Sam is also joined him. Okay, on the same script. Okay, sometimes Sam makes changes. Okay, makes some changes or add, to the script, and sometimes Ted makes the changes and something to the script. So, but this was leading them to meaningless script, okay, because they did not have any record of what the changes that they made it, right? When they were made some changes, or okay, so they were not able to identify whom, or when they have made those changes. So what they've done actually, so they hired a man, okay, who will keep the record of all the changes and updates made to that script. Okay, so that way actually, the problem has been solved for them. Like, that guy was able to maintain those records, who changed what and what exactly added in the script, and by Ted and Sam. Okay, so similarly, Git is a version control system. Okay, this basically means that Git is a content tracker. Okay, so just like the man which was hired by Ted. Okay, so the three script. Okay, and the purpose of the Git is to manage a project or set of files that they are changed over time. Okay, so same way the Git is going to, uh, utilized here. Okay, what exactly the version control system, right? Version control system is a piece of software that helps, teams or individuals, manage their source code. Okay, over time. So it tracks changes in a project, so that if something breaks while you're working on it, any updates made, okay, you can compare the difference between the current project and the previous project code, right? The previous version, okay, of the project. Okay, yeah, why Git, right? Now the now we know how, like, Git is a content tracker, but so Git can be used for to store content, right? And it is mostly used to store code because of the other features that it provides. Okay, so we'll discuss that in the next session. Okay, in the real time, in real life projects, generally we have multiple developers working on parallel, right? So just like the script writers team. Okay, so they need a virtual control system like Git, and to make sure that there are no code conflicts between them, right? So if you have multiple people are working, there might be a chance of code conflict. Like, the same class has been changed by you, and the same class will be changed by some other person, okay, at the same time. So that actually happens, when we are working on a big project, right? So a version control system allows developers to revert and go back to the an older version of their code in case of any issues. but so it allows you to have track of all the changes by different contributors, okay, to your project. So now we know what exactly a Git and its basic functions are. Okay, so we'll continue with the next topics. Okay, like repository and how you can create a new repository and how you can commit it. All those things we are going to discuss now. Okay, so a repository is just a file location where you can, where you are storing all the files, okay, storing all the files related to your project. So in our case, a repository will contain the code based files. Okay, so a repository in Git could be considered similar to your project folder, and Git could track all the changes happening inside this folder. Okay, so let's go ahead and check. So what exactly track changes, right? So track changes means, like, whenever you have this repositories, okay. So if you are making some changes in the code, okay. So Git is having a capability to track all those changes inside that repository, right? So if you are doing some changes in the class, so it is going to track those changes, like who changed it, and what time it was changed, and where are those files stored, all those things, it is going to track it. So GitHub takes care of this problem by keeping track of all changes that have been pushed to the repository, right? So we don't need to worry like who changed this and who pushed it and what time it pushed, and on which branch it pushed. All those things, Git will be able to track, okay, them. So the main concerns, to keep track of things. Suppose if you are working on future A, nothing else should be affected by your unfinished code, right? So what if it turns that, the future isn't necessary anymore? Okay. So what if after, you know 10 commits, okay, you notice that you took the completely a wrong approach? Okay, so for these kind of problems, right, Git is the first one to make it work as it is, fast and easy. So branching is the answer for these problems, right? Branching means whenever you wanted to work on something, so we maintain a code basically in the master branch, okay, which will be having the latest code of that particular repository. So you have to create your own future branch, based upon the master branch, and we have to work on those future branches, you know which is like, mostly used for only your purpose. Okay, so if you're using your own future branch, that means you don't require to worry about those those problems. Like if you've done some issues, if you've done some changes which are like which are not useful, or which are not properly coded, you can easily revert back that. Okay, because that is only the branch that is used by only this developer. So save time, right? Why? Imagine that every time before moving your mouse, okay, you would have to wait for 5 seconds. So it's like, it's not like good way, right? So with version control, it's quite the same. Okay, so we're also only talking about a few seconds per command, but it quickly adds up in your workday. So Git, however, it is very fast, to do all these things, all the commands, whatever we're going to discuss, all these commands are very fast, okay, to perform all this. So the next one is undo mistakes, right? So as we discussed, like, when we are doing the branching, so if you wanted to correct the last commit, whatever you have done, you can still, uh, you can still revert, okay, the whole commit. You can, So whatever the problem that it is, right? If you why you wanted to undo your mistake, right? Git provides all those things, like to revert back your committed code. And if you wanted to, if you want to restore the deleted files, or something else, you can still do, still you can still you know do them, because we were working on, we were having enough restore delete commits. Okay. Delete, we have like lot of commands, okay, that can be done. Restore your files back into your branch, or else you can just leave that branch, and you can still continue with the master, creating a new future branch for your code changes. That would be simple, right? Okay. So let's discuss more about GitHub, tomorrow. And whatever the topics that we discuss, please go through them. And if you have any questions, let me know. Yeah, that's all for today. Thanks.